So now let's continue with our lesson, and we are going to work on from page 6 onward, and hopefully we can finish all of the pages including the examples. From the previous day, you were able to watch videos from the College Board website, and it gives you an idea what is vector from a different person explaining it. So in this year's lessons, you might watch, or there will be some opportunities for you to watch some videos from the College Board websites or other sources, and it all depends on um, on the topic, and then it will give you the opportunity to validate what information you might get from me and from other sources. So let us move on with frame of reference. So as it states here in your notes, all problems need a defined orientation so that everyone working on the same problem sees the problem the same way. So it is not open for individual interpretation. So every time you're solving problems in physics, there is always what we call a frame of reference. We cannot just make judgment based on what we see, but instead we have to validate things that we see with other people who are with you in the class. So for example, so you see this Cartesian coordinate system, or the x and y coordinates. So where we have 0, 90, 180, and 270, as I mentioned in the previous video, or previous days like Monday, when you were introduced to vectors. So let's say there isn't any of those x and y coordinates that you would see in real life. However, there is an imaginary x and y in everything. So for example, I want to figure out, let's say I have this beautiful tree over here, and then I do have, let's say, you have yourself right here, and then you want to figure out your velocity, or how fast are you moving away from the tree. And then at the same time, your friend, two of your friends, are moving away from the tree from different directions, and you want to figure out everybody's location at a certain time. So based on this illustration, who do you think is running faster? Is it, let's say, so I mentioned earlier that this is you, or maybe let's just call it A, and then person B and person C. Person Alicia, hey Bobby, and then Carlos. So you're all moving away from it. By just looking at the distance, you will say definitely that C is traveling far faster compared to A and B, and it's all because of the frame of reference. So the frame of reference, you'll see how fast they're moving. So let's say it's certain time t. So who traveled the fastest, or who traveled farther? Of course, farther away is C, so it means in shorter distance and time, it means that you're traveling faster. Now, that's besides the point. So if I'm going to draw top view, so let's redraw this. Okay. Let's say I do have an x and y coordinate from this section. So whose direction is 0? So if you're moving away 0 degrees, this one is 90 degrees, this one is 180 degrees, and S is 270 degrees. So therefore, right away you will notice that this x and y coordinates actually do exist, but it's in an imaginary form. So you can tell the direction. Who is moving negative along the x-axis? If this is your x-axis, Anything going to the left is considered negative, and anything going to the right is positive. So therefore, you can express from here negative x. So we can say right away that A is traveling negative x, while C is traveling positive x. How about B? B is negative y. So that's the reason why we need to have a frame of reference. Now, a single point of frame of reference. Now, what if there is another object? Let's say there is this rock right here. Okay, so let's say this is a rock. You added the rock right here. And then, let's say a student is trying to solve the problem. So which one is traveling negative, which one is traveling positive? So anything positive or negative, or frame of reference, how fast is it moving? So what if you compare, let's say these two students or this person, you're using a frame of reference with respect to the rock, while C and A, you are using the tree as your frame of reference. Will you be able to compare their motion? Will you be able to compare their velocity, to be exact, because that's a form of vector. Velocity is a form of vector. However, speed and velocity are identical. The only difference is the direction. So in our case, if we use two different points of frame of reference, therefore you will not analyze the problems the same way as other people are analyzing it. So that's why a single frame, a point of reference, is very important when we're trying to understand and analyze problems. Now, reporting direction using coordinates. I think this is self-explanatory. It tells you if it's negative or positive, and I already used this as an example right here, where you have the positive going to the right, going to the left is negative. So let's say over here, that is right, negative is left, y, when y is positive, let's move up, let's move it up. So y is positive, meaning it's going up, and y downward. So when a vector lies between two axes, okay, axis reports direction as an angle in degrees measured counterclockwise. So it means it's going the opposite direction like this. So the angles measured positive is counterclockwise. If you're measuring angles from 0 and then it's going clockwise, any angles that you measure will be in negative form. Okay, so what do this thing means? Okay, so let's draw a line on arrow pointing at this example. It's moving, so let's say this is your vector. Example vector number 1. Vector v number 1, or A. Let's use vector VA. What is the direction in terms of angle? I'm hearing people saying we don't know. If I look over here, what is the angle? So that will give you 0 degrees. How about if it's moving the opposite direction like this? So that is vector B. Let's call it vector B. And that is 180 degrees. If it's going upward like this, so let's call this one vector C. The angle is 90 degrees. If it's going down, which is vector C, or vector D, that is 270 degrees. What if the angle is measured at a certain angle like this? You will seldom encounter this in terms of kinematics. However, in the future lessons in forces, especially dynamics, where angle is involved, especially on an incline or decline, yes, it is important to know the angle. So let's call this one example of vector E. Vector E, so therefore what is the direction? So you measure this angle, and this angle is represented by angle theta. So this is your direction, angle theta degrees. Now what if my next example will be vector letter F, and it's measured this way. So vector F. It's simple. There's two ways on how to measure it. You measure it this way, from 0 to this angle. So this will be theta, angle theta. How about this section right here? Can we use this to measure? Yes, definitely you can use this to measure. And according to your math class, this is a supplementary angle because it's a 180 degrees. So therefore, how do you figure out the angle over here? Let's use another letter to represent the angle. So the direction is going to be how much? So this angle right here is 180 degrees minus that angle theta. However, if you notice which one is bigger, okay, so that's 180, and then this one right here. So meaning, since this one is a greater opening, for sure that this measurement will always be negative. So this value will be negative, and this is all explaining your math class. If you need review on your math class, math skills, it is proper for you to start reviewing or understanding and studying your math skills. Okay, especially on angles, especially with triangles, geometry. Okay, so let's continue. Let's pause and continue to page 7. Now we're back here and with page 7. So continue with the text. Negative vectors, a vector with same magnitude, numerical quantity or length, but opposite direction. So, for example, I have this vector. Let's call this one vector A. So if I'm going to draw a vector that is negative to vector A, then the first thing I should do is to take a measuring device, and that measuring device you're going to use is definitely not a scale, but instead we're going to use something like this one, which is in metric form. So if I'm going to take this from 0 all the way to 2, so it's approximately 2. So what I'm going to do is just draw another vector. I'm going to draw a vector. I'm just going to say this is vector B. But vector B is negative of vector A because it's the opposite direction. Okay, so that's the explanation about negative vectors. Now, you will say, oh, it's along the x-axis. How about if it's not along the x-axis? Let's say it's right here. So this is the original vector. Let's call this one vector C. How do you know a negative vector of vector C? Again, all we have to do is draw. This is approximately 2 also. So what I'm going to do is draw another one. But this time the arrow is not pointing upward, but instead pointing downward. So now I can say that vector D is simply equivalent to vector A, vector C, but it's the negative version of vector C. So that is what negative vectors are. The opposite of the first vector. Equal vectors, self-explanatory. The lengths, okay, so the length and direction should be the same. Okay, so equal vectors or length, same direction, so they're pointing at the same way. So for example, three vectors. So let's have vector A, vector B, and then we have vector B, C. So what do you know about the different vectors? So we can say approximately that vector A is identical to vector B and identical to vector C. I'm just saying it this way because when you will be taking the test, there are some questions about, oh, are they identical? So for example, if I have three vectors, one vector, assuming that they're all the same length. So let's say this is example problem number 1, where we have vector A, okay, vector B. The intention is to show you that they're equal. And then I have vector C like this. Assuming that the measurement done over here are all the same. So what can you say about vector A? So if I say vector A, vector B, and vector C. So you have to indicate what did you observe on the drawing. So if you notice that they're all the same, then we can say that VA is equivalent to VB and VB are equal to each other. So VB is equal to VC. So now we can say that our vectors are identical. So for example, these are the forces. We're talking about forces. According to the College Board website, they're talking about forces. Yes, forces is a form of vector. Velocity is a form of vector. So basically, the use of vector is not only limited to kinematics, but it's also going to be used in almost all of the topics in physics. Second example. So example letter or number B. Number 2. Number B. Letter 2. So we can say, let's say I have, so this one is VA, and then I have V of B. Okay, so we have V of C. So you want to make a statement. Okay, so you want to make a statement comparing those three vectors. So first thing that I notice is that V and A and C are the same. Okay, V and A are the same. So we can say that V of A is equal to V of C. However, what can we say about V of B in terms of VA and VC? So VB, it's too obvious that VB is greater, so therefore we can draw this mathematical symbol where it says that if V of A and V of C are equal, but they're less than V of B. Okay. Now we have to put a parenthesis to complete our statement, meaning that what's inside will be less than of V of B. So I want you to soak in, to understand this example right here. I know it looks simple where it says equal vectors. However, sometimes the mathematical interpretation of the statement is something that most of you are confused. Okay, now let's continue with vector notation. Vector notation is just meaning how do you represent vectors. So the following examples are always are ways to represent the vector. A 50 meters in the plus x direction or along the x-axis, which is also known as the horizontal axis. So in case you're not aware, so any line like this, it's called a horizontal line. So this one is your x-axis. X-axis is also known as your horizontal axis. Horizontal axis. When it's a line that is along the y-axis, A y-axis is also known as a vertical axis. So in physics, we don't talk too much about the x and y coordinate system. However, we change it into vertical and horizontal. Because in real life, we don't really see the x and y coordinates in real life. But instead, we can say, oh, there's a vertical line or horizontal line. Okay, the 2 on the left would be used to text in text describing the vector, while 2 on the right are used in diagrams. Okay, so I will divide the notes into 2, one on the left and one on the right. So it says here 2 on the left would be used to, in text describing the vector. So for example, we have 50 meters positive x direction. So we can say 50m, and then let's describe right. Okay, so right. Or we can say 50 meters positive x-axis. Okay, positive x-axis. So these are some of the ways on how to describe represent vectors using words. Now, how about on the right side? So it says here, while the 2 on the right are used in diagrams. So usually we'll just put what plus 50m. So that's what this is what's the most common one that we put. Okay, 50m. So it means 50m along x-axis, or we can put 50 meters 0 degrees. So we all know when it's 0 degrees, it's going to the right. Okay, so assuming that it is specific that we are talking about a certain axis. So if it's mentioned along the x-axis or horizontal axis, and then they give you this kind of information, therefore that's your text. Now in solving problems, sometimes you will see this, which is 50 meters positive if it's along the x-axis or horizontal axis, so it means it's going to the right. 50 meters 0 degrees, it's also going to the right. So let's pause and let's move on to page 8. So now we are on page 8. When we are solving this, or as we go over this topic and solve some examples, and if you feel confused about the way it's being done, there's another video on review with I was about to say thermodynamics, a review on trigonometry, trigs about triangles and angles. So let's move on. So components. So when we talk about components, we're discussing about the x-axis and then the y-axis. In your math class, if you have two numbers, let's say I have 7 and let's talk about another number, 9. 7 and 9. And that is supposed to be plotted in your x and y coordinate system. So what value is 7? So there's no need to argue that 7 is represented in is a representation of the value of x-axis, and 9 is simply your value along the y-axis. So x and y coordinate. So first one. So when we talk about components, okay, so components. So let's say draw vector A. Vector A. What are the components of vector A? Okay, first of all, okay, where can you find it? Where can you find vector A? Okay, so let's continue this dotted line. So let's say we have this imaginary line, and this is your y-axis, this is your x-axis. So what is the value of your component of this vector? Okay, so vector. So let's talk about vector. Let's say this one's vector A. So what are the components? So right away, you notice it's along the x-axis. And in your math class, if it's along the x-axis, what is the value of your y component? For sure, this one is 0. How about your x? So x, if this is your origin, and you will be able to measure how long, okay, if you were able to measure how long, so this will be your x, and this one is your other x, okay, so that's your x. So usually in your math class you would say, oh, that's x sub 2 and this one is x sub 1, so in math class. So how do you figure out this length of x? X is simply x sub 2 minus x sub 1, so that would be the value for x. So how long is this? Yes, that is the component of x. So if it's along the x-axis, you don't have any component on the y-axis. Therefore, that's a value of x. So x, we only have the value of x, but we don't have a value of y. Now, what is the direction? Is it going to the right or going to the left? Drawing shows that it is going to the right, so therefore the value of x should be positive. Okay, so positive direction. Now, what if, okay, so let's go to that section of what if. What if the next example, b is going to the right, and there's along the x-axis. What can we say about the value of your x? How about the value of your y, since it's along the x-axis? So for sure and definitely your value of y will be 0, and then x is going to be negative x, since it's going to the opposite direction. This time it's the opposite direction. That's why we are combining all those different topics that we just discussed, went over from page, I think today's lesson we started with page 5 onwards or page 6 onwards. So if this is your x and y coordinates, so this time it's moving to the left. So if this is your y, this is your x-axis. X-axis is going to the left, or the value, your vector is moving to the left. So therefore that is negative x. Okay, so let me just move it a little bit to this side so I can continue with another example. How about if it's going upward? How about if it's going downward? What are the components? So where can you find your x-axis? Where can you find those vectors? So let's combine these two vectors. So if this is your x component and this the value over here is 0. So meaning that 0, 0. 0 and 0, and this is your y-axis. Okay. So for this first example, along the vertical axis or along the y-axis, what's the value of your y? Y is positive y, and the value of your x, since you are in the origin, so your x is 0. Thank you for correcting me. It's supposed to be what? 0 and then positive y. How about this vector right here? The vector components are 0 and then negative y. So 0, negative y. Where did we see this before? It's very simple. With our topic on unit circle in your math class, if this is your x-axis, this is your y, x and y, what are the, if I draw a circle around it, assuming that this is a perfect circle, a perfect circle with a radius that is 1. So when this radius 1 is along the x-axis on this section, the value of your x is 1 and then 0. How about when it stands all the way to the 90 degrees? This will give you a point that is 0 and positive 1 right here. these two right here. So they're identical. This one and this are identical. How about when it's on this point? Negative x. So meaning this is negative 1 and 0. And how about when it's at the very bottom? That is 0 and negative 1. So you've seen this in your math class before. The only difference is it is with unit circle, but this time we are having a value of your radius that is more than just 1. Okay, so not identical to 1. Now let's move on. How about, so this is easy. Okay, so this is easy. So what if I have my x and y coordinate system? This is my x and this is my y coordinate. So what happens if I have a vector that is at this point right here, and it's measured at an angle, let's say theta? Is your x-axis 0? So if you go back to the last video, okay, is your y-axis 0? So if I'll take this point right here, so the point, and we want to figure out the different components, black and this one. So is the vector in any of the axes? Is it along the x-axis? Is it along the y-axis? For sure, all of you will say that it's not along the x-axis, it's not along the y-axis. So definitely, none of them will be 0. None of the components will be 0. The only time the component will be 0 if and only if they are along the axis, as shown in the first part of today's video. Now if I'm going too fast, you can go slow down a bit and then go over the video multiple times. So if I'm going to project a line right here, oh, this is the value of your x. If I'm going to project a line right here from my dot, assuming that that's a perpendicular line and that's a straight line, so this is the value of your y. So therefore we can say that the component will be x and y. Oh, so what if, you know, something about this one. If I am going to draw this line right here, isn't it this line is the same as this line right here? Or if you want to see this one right here. So if we have this angle right here, and then we have this one. So therefore we can just produce another triangle. And that triangle, so based on the other video on trigonometry, I can form this angle, which is angle theta. And this will be the same in terms of my x. Okay, so this is my x component. If this is my y right here, can I just transfer it right here? So the y at that point will be the same as this y right here. So the height from this origin, from the end at point x, is the same height when we are drawing a projection from that point all the way to your y-axis. So we can say that this is your y-axis. Okay? Now, if this is your radius, which is also called our resultant vector. So if this is your radius, we can also call this one vector now, because we're talking about vector. Vector b or vector v. What is the value of the x component? Okay. So x component, if this is your x component, so therefore we can say that x component is simply whatever that hypotenuse is. Okay, so as if you watch that video on trigonometry, this is your adjacent side. This one is your opposite side because it's opposite this angle. So anything in front of you is called the opposite side. Oops, opposite O, not 0. So that's letter O. And this one is letter A to represent adjacent. And the longest leg is considered your hypotenuse. So hypotenuse, adjacent, and opposite. So therefore we can say x is simply your adjacent, and every time you use the word adjacent, that means it's cosine. So katoa. So x is simply r, which is the resultant vector, or sometimes we want to use vector v. You know what? Let's put vector. Whatever that vector is, multiplied by cosine of that angle, cosine theta. To solve for the y component, that's v, and that is opposite, so therefore your opposite will be sine. So opposite over hypotenuse, so that's SOHCAHTOA. Opposite, which is your y, v times sine theta. So this is how you figure out the values. So now we can say that the coordinate is simply whatever that length is. Okay. For x, that is v cosine of that angle theta, while your y component is simply v, which is vector, multiplied by sine theta. Okay. So let us pause as we move on to the next page, page number 9, as we solve for examples. So here's our first example. We have this vector, maybe it's force or even it's velocity. So if let's say it's a word problem, a ship is traveling from the port and leaves the port at the bearing or at an angle 37 degrees, and it is traveling at, let's say, 10 knots, okay, 10 nautical knots per hour, or maybe meters per second, just for the sake of easy calculation. So 10 meters per second. So now let's solve for the different components. First thing, is this one in the x-axis, or is this on the y-axis, or horizontal or vertical axis? So if you notice, there's an angle already, so it tells you that there should be two components. Simply, okay, so let's do this simple. So there should be two components because it is not along the x-axis, or it's not along the y-axis. Now we can solve for x, which is vector multiplied by, since x is cosine right here, to properly label this, ladies and gentlemen, you are not supposed to draw any arrowhead. We know that this one's going up. We all know that the x component is going to the right. However, during the test, here's the rule. You cannot draw any arrowhead, and your components must be drawn with dotted lines. You cannot draw a solid line, so be careful. If you draw a solid line, that could mean that your answer will be incorrect. So during the test, they're very strict about diagrams. So dotted lines, you know which one is your x, you know which one is your y-axis. There shouldn't be any arrowhead to denote the direction. So v cosine theta, and then y is simply v sine theta. This one is if and only if it's measured along the x-axis. The angle is measured along the x-axis, so the measurement's right here, counterclockwise. So let's plug in the values, which is 10 cosine of 37 degrees, and then the other one is 10 sine 37 degrees. This one is very simple. All you have to do is just use your calculator and simplify it. Okay, so let me use my calculator. So first one, that is cosine of 37. So cosine of 37 degrees, so that's 0.799 multiplied by 10, So your answer is 7.99, whatever the unit is of that vector. Next, we have sine of 37. Let's multiply it by 10, and that is 6.02, whatever the unit is. So therefore the components are 7.99 and 6.02. So in your math class, if you want to figure out this one right here, so it means that point, if you're going to plot it, that is 7.99, and then the other one is 6.02. So those are your components if you wanted to plot this. Next part. Next example, where you have a vector that is 12. Now, what is the angle we're going to use? That's a good question to start with. So, first part, let's draw it this way. So we have x is equivalent to vector, whatever that vector value is, multiplied by cosine theta. And then y is equivalent to v sine theta. Now, before we jump in, we all know that the value of v vector is just simply 12. Now we just need to analyze that what is the value of the angle. This one is kind of different, cosine, and this one is sine. It is really different because here the angle is measured from the x-axis. The only time that you should use this is if the angle is measured along the x-axis. In our example, I'm going to draw this as an imaginary line. So this is your x-axis and this is your y-axis. So it can be extended. Now if you notice, the angle 30 degrees cannot be used because it is not measured along the y-axis. So x-axis. So what is the value of theta instead? Okay. We all know that the intersect between the angle that is formed between the x and y axis is 90 degrees. So therefore we can say 90 degrees minus 30. 30 degrees is simply equivalent to 60 degrees. So therefore we are not supposed to use 30 degrees. Instead we are supposed to use 60 degrees. So by plugging in the value of 60 degrees, 60 degrees. So you will finally have your answer. So this is very simple. It is not complicated. So it's not as complicated. So that's cosine 60 degrees times 12. So that's 1/2. So that's 6. And then sine of 60 times, okay, sine of 60 times 12. So that is 10.39. So 10.39. So the components are as follows. X is 6, Y is 10.39. So these are your components. So if you wanted to figure out those dots, or that the component of dot, 10.39. There you go. Now there's another way on how to solve this. Okay, since it is measured along the y-axis, we can just flip. Okay, we can flip something here. Okay. Here's another solution which is faster. Every time it's measured along the y-axis. So this one right here, theta. Okay. So theta is along the y-axis. So meaning it's measured from here to here. This one is from x going to the direction. All we have to do is change your cosine. Okay, change your cosine into sine. So V sine 30 degrees. And this one is V cosine of 30 degrees. So meaning that is 12 multiplied by sine 30 degrees, 12 cosine 30 degrees. And you'll be surprised, I hope you're not surprised, that the values are going to be equal. Now, let's take a look at what is sine 30. Sine of 30 times 12 is also 6. And then cosine of 30 times 12 is 10.39. So it's giving you the same answer. So this is a shortcut instead of doing this, trying to figure out the complementary angle. Complementary angle meaning 90 minus whatever that measurement of an angle is from your y-axis. And then you can solve for the coordinates. And the coordinates are simply 6 and 10.39. Next and final example. This is complicated because the angle is 0. Because it's along the x-axis. So, if it's along the x-axis, what do you know about the y component? Okay, so x and then we have y. Okay. You want to make it, you want to apply what we learned from the previous lessons. Okay, so what is it? V multiplied by cosine theta. And this one is V sine theta. X and y coordinates. What if it's like this? This is your y component, this is your x component. What is the angle when it's facing that direction to the right? So meaning that is 8 multiplied by cosine of 0 degrees. And then that is 8 sine 0 degrees. So what is cosine of 0? Cosine of 0 is simply 1. So 1 times 8 is 8. And what is sine of 0 degrees? And that is 0. So any number multiplied by 0 will give you 0. So therefore, the x and y components are simply 8 and 0. So this is how you prove why is it that the value when it's along the x component, the value of your y is always going to be 0. The mathematics behind it will show you and justify your answer. Okay, now let's continue. Now, given the component, so we have two components, the x and y. So now let's figure out the vector. So for example, 16 is your x component and then 12 is your y component. What you can do is transfer this line to the other side. According to the video from the College Board website that you've watched, it needs to be from head to tail or tail to head. So if I am going to project this line right here, so what I'm going to do is transfer. Okay, so what I'm going to do is transfer this. Projecting this one right here. And I am going to project this right one here. So meaning I'm just going to transfer this to that section. So that's transfer. Let's transfer the whole line right here. Let's push it until we have what we call that 12. Okay, so that component is right here. So now that is 12. So this is your 12, and you want to figure out the vector. So the vector is from this point to that point. So figuring out what is this vector. Okay, what is this vector? So it says here, given the components, determine the vector. Okay, let's add one more. Okay, let's add one more. And that is, what is the direction? What is the direction? Okay, so have you noticed what kind of figure do we have here? Okay, the figure is a right triangle. You have a triangle with 90 degrees in one of the interior angles. So how do you figure out the longest side of your angle? Okay, so longest side. So for sure, looking at this one, if I'm looking at this problem, this is 3. So what is 16? So that's 4. Okay, 4 times 4 is 16. 3. So meaning this one should be equivalent to 20. Okay, so this should be equivalent to 20. Okay, because this is a special triangle. So 20. Okay, why is it going to be 20? How do you figure out the longest side? According to your math class, there is what we call the PT, or Pythagorean theorem, PT, where the longest side, okay, so isn't it in your math class, you would say that the longest side, which is the hypotenuse, the square of the hypotenuse is equivalent to the sum of the square legs, which is the opposite or the adjacent square plus the opposite side square. So this is what we call the PT. Now in order to solve for, but this time we're not using the hypotenuse, but what is your hypotenuse? That is your vector. What is your vector? The square of the vector is equivalent to the sum of the x component plus the square of the y component. So therefore the velocity or the vector can be calculated by taking the square root of both sides of the equation. So therefore we have the sum of the square of the opposite and adjacent side, which is your x and y component, is, and then you take the square root of it, is your vector. Let's plug in the values. Square root of x, which is 16 square, plus 12 square. So what is it? Square root. Let's use the calculators. So that's 16 square. Square. So that is 256 plus, what is 12 square? 144. You add those numbers, what do we have? Plus 256. The square root of 400. What is the square root of 400? Is simply equivalent to 20. So I was correct. 20 because it's a special triangle. So if you divide both sides by what? Divide all of them by 4. So this is equivalent to 4. This one is equivalent to 3. So this is a 3, 4, 5 triangle. So that's why. If you see that pattern, that one side is 3, one side is 4, the longest side will be 5. So that's a special triangle. 3, 4, 5. Now, how about direction? So what is the direction all about? That's simply the angle, theta. So if we know our opposite, we know our adjacent. That is what we call TOA in the trigonometry function. So therefore, in order to figure out your angle, simply theta is the arctangent. So we're using tangent all the time because we know the x and y components. arctangent of whatever that value is, and that is your opposites, so that's y over x. So y over x, which is also known as your slope, y over x, the change in rise, the change in the y component divided by the change in the x components, which is rise over run, is simply your slope, and that is the trigonometric function of tangent. So arctangent, -1, arctangent. Okay, so arctangent of 3 over 4, so 3/4. So therefore, what is the direction? Let's use your calculator to solve it. Arctangent so arctangent, tangent of 0.75, that's 3/4. So that will give you an angle of 36.87, so we can just say approximately 37 degrees. So therefore, your vector is 20, and then your angle is 37 degrees, or your direction. So this will be your answer. So the notation. So this is for first example. Second example. Okay, second example is this time we want to figure out your x component, or your to solve for the vector itself. All right, so first thing is to move this line right here, to draw a projection. So let's draw a projection and transfer that to, in order to have the heads and then the tail goes to the end of it. Okay, so now let's draw this. So this will be 2. This is your x component. It's just -3 because it's moving to the left, while this one is positive or -2 also because it's going downward, so that's your y component. So y and x. And in order to solve for your vector, what is that vector right here? So you are on the third quadrant. So we have negative and negative. So this will be your vector. And what is your angle? Theta. Same procedure. In order to solve for it, we have our x component, we have our y component. So vector is simply the square root of x squared, the square root of x square component, y component square, plug in the value, so the negative doesn't really matter when you put it inside because you cannot take a square root of a negative number. That is considered an imaginary number. However, since there's a square on each value, so for example -2 square, that will give you +4. Same thing right here where you have -3, 3 times 3 negative, that will change into positive. That will give you 9 positive. So square root of -2 square plus -3 square. And that will give you the square root of 4 plus 9. And what is 4 plus 9? Square root of 13. If you want to stop there, you can stop there. If you don't have a calculator. If you do have a calculator, you can continue. Just simplify it. Sometimes in the multiple choice questions during the test, they will just give you square root of 13. And then you're trying to simplify it with your calculators. How come I don't have any selection? If you go back one step, you will find out, oh, that's the answer. Okay, so square root of 13. Okay, so now, what is the square root of 13? So that is 3.61. 3.61. 3.605, or just rounded to two decimal places. That's why it's 3.61. Angle, so arctangent. So that will give you y over x. Again, the negative will not cause any problems because the negative divided by negative is going to be positive. So what is the tangent? Arctangent. So you can see value of y is -2 divided by -3. So 2 over 3, which is 2/3. So that's 0.666. Arctangent. Tangent, as long as it's not hyperbolic. See, arctangent. So 2 over 3, close parentheses, equals 33.7. So your angle is 33.7, 0.697. So 33.7 or 34 degrees. So we can say approximately this is 34 degrees. So therefore, we have our vector with a magnitude of 3.61 and direction of 34 degrees. So let us pause and let's go over page 11, 12, and 13. So now let's continue with page 11. Page 11, so let's talk about the basic vector addition. So resultant is the answer for the sum of all vectors. Okay, so let's review. If you're adding two numbers, what is the answer? What is the answer for addition? It's the sum or total. When you multiply two numbers, the answer to a multiplication process is called the product. A division. What is the answer for division? So you divide a number by the divisor. That is going to give you an answer that is called quotient. Okay. And then so on and so forth. With subtraction, we have the difference. So minuend minus the subtrahend will give you the difference. Resultant is the answer for vector. So you've seen this in the College Board video. The resultant R is simply the summation, which is the symbol for sigma. The summation of all the vectors. Okay? The summation of all the vectors. So meaning you add all the vectors. So I could say the resultant is simply vector 1 plus vector 2 plus vector 3 plus dot 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 2 all the way to vector n. Okay? Or sometimes I would say R is simply vector vector A plus vector B plus vector C plus dot 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 plus vector all the way to sub n. Okay, so never-ending numbers. Instead of writing it this way, that's why we have the shortcut, which is the summation of all the vectors. Now, be careful because there's no such thing as subtraction. However, there are negative vectors, so when you add those numbers, okay, when you add those numbers, negative, positive, you just subtract it, and take the sign or the direction depending on which one's greater. Do not subtract, because when you subtract, remember, for example, like this, y. What is the answer when we have y plus x? Okay, or maybe we have y plus negative x. So what will be your answer? This one is simply y plus x. Right here, it will be y minus x. Now, if it is subtraction, it's going to be different. So what if we have y minus positive x, which is this same one over here? So what will happen is that you will change this into y minus negative. So you change this into the operation of addition. So y minus x. So this will give you y minus x, not y plus x. Okay, so y minus x. How about this part right here? Y minus negative x will give you a different answer. So y, change the operation to positive, to addition, and then your negative change into positive x. So therefore your answer will be y plus x. So that's why we need to be careful not to use any subtraction in vectors, because the standard operation for subtraction of integers is you have to change your operation into addition and change the subtrahend into the opposite sign. Too much about math class. Let's add. So having this direction, you add them. Opposite direction, then you have to subtract. Now, another thing that you must remember, you can only add values along the x-axis and add the value along the y-axis. If they're 90 degrees apart, then we will apply what we just did in page number 10, and that is the Pythagorean theorem. So now, example number 1. If an object moves 10 meters in the positive x direction and then moves 5 meters in the 5 meters in the positive x direction, how has it moved? Okay. So for example, let's have 10 meters. 10 meters. So you start from 0 and now it's 10 meters. Then afterwards it moved. By the way, that's positive. This one is positive 5 meters. So if I will take the resultant, what are the vectors? So let's solve for the sum of all the vectors. So that's positive plus positive, positive 5. Okay, so positive and positive. So therefore you add those two numbers, it's simply 15 meters, and it's also going to be positive because this one is positive, this one is positive as well. So positive and positive, so meaning your answer will be positive 15. So it will continue to move to the right and it will not move to the left. How about this next one? If an object moves 10 meters 30 degrees and then moves 5 meters 30 degrees, how has it moved? Okay, so this one is a little bit trickier. Now, let's say this is your origin. So it means you move 10 meters at an angle, and that angle is 30 degrees. And then you move, and that is 10 meters. And then you move at another 30 degrees, 5 meters. So that's 5 meters at another angle of 30 degrees. Okay. Now the question is, how has it moved? So you want to figure out how far did it travel here. That's your x. How far did it travel here along your y? Okay, so x and y. Okay, so what is your resultant? along the x-axis. That's simply the summation of all vectors on x. And then how about your resultant along y is all the summation of all the vectors along y-axis. Now, x. Okay, so how do you figure out the x component of the first one? Okay, so velocity, or not velocity but vector. Vector of x. Vector of x. So let's talk about the first one, which is 10 multiplied by sine or cosine. For sure you would say it's cosine of 30 degrees. So what is v of x? What is 10 of cosine 30? Let's see if we can finish this video or this lesson today, so you can move on with the assignment that's due Monday. If you don't see the video about trigonometry at this moment, maybe you could see it later. So first one, that is cosine. Cosine of 30. Cosine 30 times 10. So that's 8.7 or 8.66. That's the first one. So v of y, v of x for the second one. So number 1 and number 2. So we have 5 cosine of 30 degrees. So what is your v of x for the second one? So that's cosine of 30 degrees. Oops. So it's just going to be half of 8.66. So how much is that? That is 4.33. And all of them do have units, and that is meters. Okay. And they're all moving to the right. They're all moving to the right. So therefore we have 8.66 plus 4.33. And we have a value of Rx. That is 12.99 meters. So meaning your x, or this object, moved 12.99 meters along the axis. Oops, I didn't know that you weren't able to see it. Now in terms of Ry, for number 1, so v of y, that is 10 sine theta, which is 30 degrees. So this will give you v of y, that is equivalent to 5 meters. And then the second one, v of y for the second number. Okay, so you can see it. That is equivalent to 5 sine of 30 degrees. So v of y is simply 2.5 meters. So you could see it clearly. R of y is simply 5 plus 2.5 meters. So therefore that is 7.5 meters. That's very simple. Okay, so this is very simple, not too complicated. Now if you want to take the value of the vector, how far did it travel? So the r is simply the square root of rx squared plus the same process. So r of y squared. So rx squared, square root of 12.99 squared, plus y, that is 7.5 squared. So let's just take the square of those numbers. Let's figure it out. Square root of, open parentheses, which is 12.99 squared, close parentheses, plus open parentheses. And that is 7.5 squared, close parentheses, and let's close it and press equal sign. So that will give us an answer that is 14.99, 14.99, and that is, or approximately 15 meters in terms of its direction. Now if you want to figure out the direction, which is your tangent, let's figure out arctangent, -1, and that is y, so r of y over r of x. So what is your tangent, arctangent? What's r of y? That is 7.5 divided by 12.99. So you're moving at a certain angle at the direction of arctangent 0. Arctangent, that is 7.5 divided by 12.99. Close parentheses. So that is approximate. That is also 30 degrees. So you're moving at 30 degrees. Same direction. Never change direction. 12.9. Okay. So approximately 15. You could say, you could just add it, this one, Mr. Rivera, 15. Because it's the same direction. You could. But if you wanted to show and justify your answer, why is it 15 and why is it 30, you could show all of your work. Alright, so what I want you to do as your exit ticket maybe is to work on example number, the examples in number 12 and 13. Okay, 12 and 13. So this will be your exit ticket for today. Make sure you take off that portion, 12 and 13, and submit it at the end of the period, so your teachers will be able to put some grade for you for the week. Okay, hope this gives you an insight on what physics is in terms of the application of trigonometry and other math skills in real life. Okay, and I can't wait to be there. I'll be there very soon. Thank you.